Because people keep stealing them. So there's not many left. Okay, I have my poorly drawn unicycle. Let's draw a 30-degree angle. Ooh, I don't like that. Amy, what axis do I always start with my degrees when I'm talking about my reference angle? Do I start on the X or the Y? Yep, I'm going to start on my X and then I'm going to go 30 degrees up, right to a point on my sickle. This line is also called what on the unicycle? Radius, which is always 1 for my unicycle. Oh. One. So this was 30 degrees. Then I'm going to make a triangle, so a point down and a point over. But no, this pencil's right there in the little bin basket. Okay, 90 degrees here, and it's a 30, 60, 90, so this one is 60 degrees. Okay, our geometry people should definitely know this next question. Who remembers my 30, 60, 90 triple? Yeah. Do we remember? Yeah, so my other one was square root of 2. Two S's over here, yep. Of 3. Yeah. It's 3. So my short side is always the S. My last one here is my hypotenuse always. So this is 2S. And this is S square root of 3. Little geometry review. So we already know one side. We know that 1 hypotenuse equals 2S. So Chetty, I want to get S all by itself so I can figure out the other sides. What can I do to get S all by itself? Yep, divide by 2, divide by 2. So you know now that S equals 1/2. So we already know another side of our triangle. Hypotenuse is 1, and this side over here, which is just S, Chetty told us is now 1/2. What is my third side right here on the x-axis? What would that one be? If S equals 1/2. Say it louder, Liam. Yep, and I'm going to put that all together. So square root of 3 over 1/2. Oh, over 2. Great, we already found all 3 sides of this triangle. So same thing as yesterday. We now know this point right here, which is X and Y. What is X again? Is that sine or cosine? Yep, cosine of theta. And what's Y? Yep, sine of theta. Boom, boom. So what is my X value right now? How far over did I go in the X direction? Yep. What about my Y value, Kennedy? How much should I go up? So I went over square root of 3 divided by 2. How much should I go up? 1/2. Perfect. You just found another point on a unit circle. And we can reflect this in each direction. So, Freddie, what quadrant do you want to go into next? Not 3 or 1. Second one? Okay, everyone tell me when I stop at the second quadrant. Second quadrant. Okay, great. And I need to use what method to draw my triangle correctly? Yep. Yeah. This one? Hypotenuse is always 1 in a unit circle. So I go down, up, across, so draw another diameter, and then up. It would probably look better than this. Okay. So this is my triangle over here. So this is still my 30 degrees. This is still 60. This is still 90. And I'm in quadrant 2. You guys know what's positive and negative over here, right? What's negative? Okay. What else? Okay, y is positive, yep. So that's sine and cosine. What are we missing? Yep, tangent. Is it positive or negative? Yep. So tangent is going to be, ooh, let me get a darker color. Tangent of theta is going to be negative. So what is cosine of theta over here? Yep. And what about sine? Yep, positive 1/2. And then what is tangent? What goes on top of tangent? Sine or cosine? Yep, sine. So we have 1/2 over what? Yep. I'm going to move this down for a second. Tangent of theta equals 1/2 over negative square root of 3 divided by 2. I want you to simplify this fraction down to one full fraction. Talk to your partners next to you if you need help. So it's 1/2, so that's sine over cosine. Multiplication, flip our fraction. So we're going to keep 1/2, change multiplication, and then flip our second fraction. What is that as a fraction? That's the thing. Oh, we need in fraction form. So Kennedy, I have a 2 in my numerator and 2 in my denominator. What happens to these 2's? Sure. Yeah. So multiply over, right? Across. So I got 2 times negative 2 add 3. Can you simplify that right now? Okay. These 2's cross right out. They disappear. So now I have 1 over negative radical 3. It can be out front. For right now, well, I'm just going to keep it. With the radical 3, yeah. Now I have to multiply by something to get the radical out of the denominator, because we can never have radical in the denominator. Yeah. What is it, Kennedy? Yep, over square root of 3. This would simplify to negative square root of 3 divided by 3. So that is tangent at this point. And it's negative. So at this point, on the other side, what was tangent at this point? It is positive, yep, and it's the same thing. So that was tangent at that point. Okay, let's put this in the unit circle. Okay, I'll give you a second. What degree are we going to start at? What degree? Yep, so at 30 degrees. So I'm over here. And we found out that our point was me radical 3 over 2 and 1/2. And tangent of theta was what, Michael? Yeah, what did we simplify that down to? Okay, that was over in quadrant 2. So if I'm in quadrant 1, would it be positive or would it be negative? Positive, perfect. Okay, what degree should I be going to next? So close. Look at where the denominators are. Wherever there's the 6, that's the next one we're going to. Okay, yep, 150. So over here, sign is positive or negative? Positive, and that's x or y? Yep. So we have positive 1/2 and negative square root of 3 divided by 2. And we found that tangent over here, tangent of theta equals square root of 3 divided by 3, and it was negative. Okay, where's my next denominator of 6 for radicals? Yep, 210. So we're down here. Ronaldo, what's the point? Mm-hmm. And what's tangent? Yep. Okay. Liam, where am I going to next? What radiant or degree? Yep, and what's my point? And what's tangent? Yep, negative square root of 3 over 3. Perfect. Okay, we have one more. What degree are we missing? 60 degrees. That one's yeah. Didn't we kind of already just do 60 degrees? Well, it's in the triangle 30, 60, 90. Yep. So it's going to be very, very similar to the one that we just did. Ooh. Okay, drawing another circle and quadrants. I'm getting worse at drawing circles on this. Okay, it is what it is right now. Okay, Amy told me I always draw at the x-axis. Tell me when I should stop to get to 60 degrees. Yep. Wow, so much energy from you guys. That was so quiet. What's up, Sebastian? So, tangent of theta is always sine theta over cosine theta, which is the same thing as what is sine? What coordinate? Y over x. So when we get our points right here, we're going to put x in the bottom and y up top. And then we just simplify it. So that we get it from the lengths here. So we're going to do it again. We're going to find the lengths again. Okay, so this is 60 degrees down here. This is 90 degrees, and up top is 30 degrees. So my triple again is S square root of 3, and 2s. Okay, I do the dashes. s square root of 3 and 2s. Kennedy, what was it? Okay. 2s represents what side? Yep, it's kind of like A, B, C, and the Pythagorean theorem. So it's the hypotenuse. Yep. So this side up here is hypotenuse, which is 1, which is also 2s. Down below, our short side is always s, and this side over here is s square root of 3. It's the same exact sides, except we switched them. So same thing as above. What did s equal? Yeah, still 1/2. So now we're down here. So this is 1/2. So s square root of 3, what did that simplify to? Yep, so square root of 3 over 2. So Sebastian, this is saying that this side, the distance from the center to this point was 1/2. So that's how far over I went in the x-axis. Because this is my triple for a 30, 60, 90, which you would have learned in geometry. So I always know that the short length of a 30, 60, 90 is half of the hypotenuse. So if my hypotenuse is 1, what's half of 1? So that length down there. This one, that's always s, my long side, times square root of 3. This was refresher from geometry. So we're not going to prove that this is a triple, but this is a triple. So if I want to go from my short side to my other leg that's a little bit longer, I would just multiply by square root of 3. Okay. So then, Sebastian, what's this point right here? How far over did I go in the x direction? Yep. And how much did I go up in the y direction? Square root of 3 over 2, yep. It's not the same point as above, just we just switch x and y. Yes. Okay, let's figure out what tangent over here is. So if tangent of theta is sine over cosine, which is y over x, what goes on top? And in the bottom, Brent, what goes in the bottom? 1/2, yep. So let's do our keep, change, flip. What would that simplify to, RJ? I'm multiplying right here. Lily, want to help him out? Yep. So square root of 3. So that's our tangent at that point. Okay, do we need to put it in a different quadrant, or can we do it on the unit circle? Okay, I heard 1 vote for unit circle. Okay. Unit circle it is. Okay. Yeah. Wait, flipping over, what degree am I at? Okay, and what's my point at 60? Yep, and what's tangent? Yep. Kyle, what angle will I have to be at next? Going out of 60 degrees from 60. Where am I at? Yeah, 120. And what's my point here? Yep. Yeah, keep going. What's my y coordinate? What was it over here? It's going to be the same thing. We're just changing if it's positive or negative. Yep. Square root of 3 over 2. Yep. King, which one is positive, which one's negative? So between my x and my y right here, which one is positive, which one's negative? Over here, which one was positive and which one was negative, x or y? Yep, which one, what about this one? Which one's positive, which one's negative? Yep, still the same over here, still negative x. I'm in the negative x direction. So that makes my tangent also negative. So negative square root of 3. Amy, what angle should I be at next? Yep, 240. What's my point at 240? Yep, and which one is positive, which one is negative? So close. I'm in the, if I go this way, am I in the positive or negative x direction? Yep, so that makes that negative. And if I'm going down here, am I in the positive or negative x, y direction? Yep. And then tangent would also be positive. Okay, we're on to the last one. Very last one, and we're almost done with the unit circle. And, yep, would be my tangent. Okay, we're almost done. We need to do tangent at 4 more points. What are those 4 points? Yep, okay. 0, 90, 180, and 270. Talk to your partners next to you. I want you to find tangent at all 4 points. The 4 that we are missing.
What's the issue with that last fraction you're up here? What can't you divide by?
Oh, zero. Would it be zero for one then?
Well, there are places where you're gonna get that fraction, but make sure you recognize it's undefined. I don't know which point you went to, like which angle, but well, which one are you at?
It's the zero.
So sine over cosine, right? Which one's sine?
Times the y.
Good. So 0 over 1 there. Which one are you doing? So love it. This is 0.
So this one on 9.
Yeah.
It's gonna be hard to remember.
Yeah, definitely.
No, because 1 over 0. It's just undefined. Like that number is not right. Yep, we have to use that one. But it does mean some stuff about the graph of tangent. If you think back what you did before, you get the right line to do this. Yeah, and it just gets infinitely big.
So what did we get for tangent at 1, 0? Yep, it is 0. So it should have been what over what? 0 over 1. It's always y over x. So that's 0. Okay, what about up above? Undefined, because we had, yep, 1 over 0. Can't divide by 0 ever. Yep, so over here also was 0, because it was 0 over negative 1. And what about down below? Undefined. Anyone want me to go over the math there? Okay. This lovely unit circle, we're going to take a quiz on tomorrow. The whole thing. Because you guys can already memorize it. And I know it. We're going to do it up on the boards in a second. The only thing that should be tricky is where the radians are. Pi? Yeah. That's the only difficult part. We're going to do it up on the boards and do more together. Tangent? Okay, you don't have to memorize tangent for the unit circle quiz tomorrow. Yeah. The rest of it you do. Yeah.
I'm gonna tell you guys, like, I get it. It looks like it's gonna be awful, but just lean into it and just trust. This is one of the easier things you're going to do this year. It doesn't feel like it. I assure you it is. Easier things.
So all you're gonna do is just give us a circle.
I'm gonna give you this exact sheet of paper, except nothing is on it. Like, none of the colors are on it. You know all the degrees? All the blanks were gonna be there. All you have to do is fill in the blanks. The what? You need to do all the points. This tangent you don't have to do. You need to do what's in green, what's in blue, and all of the points. Okay, let's just focus on quadrant 1. Okay, everything in blue, everything in green, and all of the points on the outside. You don't have to give me tangent on the outside. Everything where there's a blank, you're going to fill in every single blank.
It's that sheet, right?
Yeah.
Wait, you have to give it the points.
Yep.
So we have to go on the
Yeah. Do you want to know an easy way to remember the points? Okay. Okay. I just learned this yesterday because I did not realize that this was a thing. So I've been, this entire time, I had to memorize the points and I didn't do this. Ever.
Is it what I do?
The 1, 2, 3?
Oh, yeah. 100%.
Yeah, I just learned that yesterday.
Interesting.
Yep.
Yep.
Don't wish I knew this. Okay. All of these fractions, what's in the denominator? Okay.
34, 6.
Denominator.
Oh.
Yep. 2. Great. Gotta remember that. What's in the numerator here? Okay. What's in my numerator here? Okay. What's my numerator here? 3. 1, 2, 3. Now shift over. What's in my numerator here? What's in my numerator here? What's my numerator here? Okay, and what's in all my denominators? 2 over 2 over 2 over 2 over 2 over 2. No. Okay. Radicals in my numerator, the only above what number? And? Wait, those are 2's. What about my 3? Yep. Well, they're still a radical. So there's a radical here over my 2's and 3's. Yeah? Yeah.
If you don't like to change, you can keep it radical and everything. What's root 1?
Root 1.
You can keep it root 3, root 2, root 1. Okay. It's fine. It's still the same.
Yeah. Wait, just say that again.
Roots?
Yeah. Like square root or a third root.
So everything there's a 3 in my numerator, there's a square root. There's a 2 in my numerator, there's a square root. Okay, you now memorize all the points. You might not think you have, but you have. Yeah? And then you just have to remember 0, 90, 180, and 270. Yeah, I got my whole life without learning this. No one ever taught me this. I just memorized it by memorizing it. Yeah. I don't know. Maybe you should prepare for it, but we'll see. Okay. You want to go in groups and try to do it on the board now?
Yeah.
Okay. I don't know what you want back. Okay. Okay. Your bow ties and butterflies will help you.
sixes, threes, fours. Like
Yeah.
that. I can do that. But then that's
Wait, look, question 1. It's always pi over 6, pi fourths, pi thirds. We're getting to lower numbers. So this is like 6. So what's greater? 1/3 or 1/6? 1/3 is greater. So it's up there. Okay? Pi 6. There's another pi 6 down there. It makes an x as such. Those are all 6s. Okay, my 4s. They also make an x. These are all my 4s, and these are all of my 4s in my denominators. My 3s also make an x. 3's down there, 3's down there. Okay. All you're doing, pi 6, you're adding a pi 6, adding a pi 6, adding a pi 6, adding a pi 6. You can just do pi 6 and then simplify the fractions. All the fractions need to be simplified for the test. Yeah. Yep, except you have to skip the 45s because the 45s are only pi fourths. So you have to do pi 6 all around and then pi fourths for 45. I don't know yet. I'm still thinking. Okay. Good. Average quiz grade. Say it again. Yep. By 45. Yep. Those are pi fourths. So pi fourth is 45 degrees. So going up by 45 degrees. What's up, Liam? Oh yeah, go ahead. Okay, groups. We're gonna do this up on the board in groups. Why are you shaking your head? You wanted to do this. Okay. That confused you more?
I'm saying break it up then. And then it goes. So 3, 2, 1.
Put it the long way. Get 1 point.
Be sure that I do.
Wait, I didn't account for the missing people. I'm sorry. Who has a 2? Oh, you have 7.
What was that?
Okay, who has a 4? Okay, find your groups.
Who got 6, Jack?
I think you're just gonna.
Just go through.
Yeah.
Kennedy. What's the radius of the unit circle?
The radius? I don't know.
It's
1?
yeah. So if you're at the origin, you go 1 up.
Yeah.
What's the coordinate there if you were at 0, 0, and you go 1 up?
1, 0.
1, 0, 0, 1.
1, 0.
Oh.
0, 1.
Is that the point you're talking about? You don't get it?
No, it's the pie things. I don't get the tops of them. The bottoms are fine. Where are you over here?
Oh,
Like, no, the tops. Like, I don't know.
This is our board.
When you get to the part of the problem where like this is
Group 6? No, actually, go back to your group. Where you go?
Like, I don't understand this.
okay, I will swing by like
Not just this particularly. I mean the whole,
no,
like,
all
all of them.
I will we'll walk.
Shoot. We're kicking you out.
I don't know what I just erased.
Wait, can we draw?
It's an egg.
Close enough. Watch this. Perfect circle.
Like that.
Yeah.
I don't want
Is I'll let you guys go before I say. So I show you what you right. You only need to remember one.
It's 90 right here.
I don't know.
No, it's negative one. You're right. Wait, no, that's fine.
Yeah. Okay. I did my part. You guys. Like that's for radius. Yeah. So 2 pi is 4. Hey, chill out. Oh wait. But I one half. Y6.
What do we say?
How are we doing?
1/3, 5/3, 5/3.
What is tripping up the most? Is it the pie stuff? Okay, do you know your degrees?
most of them, yeah.
Okay, I bet if you know the degrees, I think there was a formula that would help us get all of our radians. So give me any degree on the unit circle that you don't know the radians of.
All of them?
Give me one.
270.
Okay, 270. If I take 270 degrees, remember I can multiply this by pi over 180, and it would automatically give me what my radius is. So all I do is do 270, divide by 180, and I would times it by pi, which I want to keep pi. So what's 270 divided by 180?
You remember pi 6?
Is that what I'm doing? For you? I don't like that one. But you can just type it in now and hit enter.
For this one will be
3 has, perfect.
4 pi.
So 3 pi has. Exactly true.
Why do we do 180?
So 180 is half a circle, and pi is also half a circle. So this is really just 1. It's a clever choice of 1.
All of them can be
Miss
used with this?
Yeah, exactly as that.
Would it be 6 pi or 4 pi?
Where?
For
Is that where she put her hand? So that's gonna be over 6.
thank you.
Yeah. So let's do another one.
Let's not do it.
4, 5.
Like, I don't know. One with a number in the top, in the end.
Okay.
Like this. Sorry.
No, it's good.
Like
That one.
what
Okay.
numbers in the
Let's do 330.
Yeah.
Degrees. Okay. So what do I have to do to it?
That. So divide by 180.
Yeah. And then you just have to write pi after it. So what is 330 divided by 180?
Are you just simplifying it?
11/6.
Yeah, so how would I write the radians?
Then just for
That's exactly right. Yeah, do another one. Let's do 250.
one more.
25, 18, or something.
No, that's not right. Let's do 240. 240 would be a bad number.
Non-right degrees.
Pi
Or
the number one. So
Okay.
this one would just be pi instead of the.
Yeah, that's it. So as long as you get the degrees on the unit circle, you can get the radians
Okay.
from that. Yep. So you don't have to memorize the radians, but it helps me memorize radians. Yeah. Okay. Check their math. 'Cause I think some of them. Yeah.
So you know how we start with 1/4 pi on 45?
Yeah.
So do we count 90, 45, 90, not 30?
Yeah.
So what happens?
It would be plus.
Yeah, we already had that. It's gonna be, yeah, 3 times 5.
Kenny's got it. She knows how to find all the radians now. Okay, wait. Someone write the degrees. Can we do the degrees? I think Kenny's got degrees. So 180 plus 30 degrees, Kennedy. Perfect.
10.
And then you skip one. And then you do another 30 degrees. Yep. And then Landon, what's in the middle of 210 and 240? Yep.
25.
Yeah.
Like, I did 3 points.
That would be 30. Actually, no. Yeah, you're right. But the 300 would be 315. That one would be 300.
What is a full rotation around a circle? What? Yep, which that
Wait, do this one too. I just want to show you. 3. So, because it's or no. You're elephant. So we write that on that. For you want lunch combo 3 5.
For that one, Landon, it's 7 pi 6. Write it.
Like, follow this pattern.
That would be this way.
What?
That would be this way.
No way.
3 is the
It wouldn't. That one's 4 pi 3. Also, I said 210, by the way. 210 is 7 pi 6. You wrote it wrong. Nope. Yeah, you're right. Didn't mean to drop that hard.
Just do it like this.
one half a little bit.
No. One. Oh, it's not good. Yeah, how you get right? Nah, that's. That's okay. Let's go over this one. Then 3.
What's
Oh, it's a square, and then a coordinate.
Okay.
Same thing here.
With these ones.
Add another this.
5, 5, 4.
Oh, I swear.
Okay, let's pause for a second.
4,
Our
5, 6.
denominators of 2 at 135. What's my vacants?
One at 135. You could break.
So I'm here, right? 135? This is line.
That's
Okay, so I'm like here,
right
right?
side.
Okay, so I go 5/4, I have 2 5/4, then I'm at 3 5/4. Yep, so I think that's what's good. So I go 5/4, 2 5/4. I'm adding up 5/4 each time because I'm adding 45 degrees. This is how many 3/4, 5. Yep.
5, 5 thirds.
You just do
Oh, this one? Yeah. Next one's 7, 5, 4.
Same thing.
Oh, or just one more. Which that means that will be 8 pi 6.
Same thing.
I can't see your hand.
Oh, sorry.
You're
8 pi 6.
11, pi 6.
11.
Like write this exact the pattern.
Oh shit, no, goes up by 2.
No, Landon, it's not a rhythm. You have to divide. It's not a rhythm.
Oh, yeah, never mind. Wish we're done. I think we may be done.
I saw what you did here with this. But
Yeah. So it's the same thing. So can we? What? This is 1, right?
Yep.
So 1, 2, 3, and you go back to same line. 1, 2, 3.
it's always like that.
Always like that. And my denominator is always 2, always 2, always 2, always 2, always 2, and always 2. Now the square roots. That's the thing you gotta remember. It's always on the 2's and the 3. So where do you see 2's and 3's in the numerator? Okay, there, here, here, here. And then after that, when you go around, you just gotta figure out where's positive and negative. And I would use the all students take cash. This tells you when things are positive and negative. Here, all positive. Here, which one's positive?
The left one.
Left one. Sign is, S is for sign. Y. Y. The Y's.
But the X's are right.
Oh, I didn't say what's negative.
I know what you said.
Oh, what's positive?
Oh, those. Oh,
What would be positive down here?
both none. Nothing.
No, nothing. Yeah. So tangent, which we didn't do. It's
Oh,
fine.
okay.
And then cosine is
Sine's negative, cosine's negative, tangent.
yeah. So
All
it's like
positive?
positive. Yep, all is positive.
Oh, those are what's
Yeah. That's how you figure out which one's positive and negative. Oh, it's the end of class.
What sign is wire?
Sign is always Y. This is how I remember it. Okay, it's X and Y, right? Okay, which one comes in the alphabet first, C or S? C. So C goes first, and F is second. Yeah. Okay. Yeah.
Like, actually, I'm starting to understand this. This week, are we done? Are we done with? Like, is it?
Yeah, it's done. I mean, we put tangent in it, but yeah, that's it. Yeah. It's
So if I know it's
Questions for me now before your quiz tomorrow on this? No. Anything? What's the hardest thing to remember? Sebastian, if I said what is 330 degrees in radians, what helps me get there? Yeah, so pi over 180. And I want pi in my answer, right?
Wait, this is a radian?
This, yeah, I want, this is degree into radians. So I want to keep pi in my answer, so I'm going to do 330 divided by 180. What would that be in our calculators? Kennedy did it for us, actually. Right there. 11 over 6. So this is equal to 11 pi over 6. Inside.
The radians are inside, yes.
How do you find like 11, 6 and all that?
This. Multiply it by that. So if you know my degrees, just divide it by 180 and we get a radians. But we should also just eventually learn to memorize a radians. Now, what quadrant would it be in, Sebastian? For 11 pi over 6. Yep, because 11 pi is really, really close to 2 pi. Okay, because that's 12 pi over 6. It's really close to that. We are in quadrant 4. Yeah. Okay, come after school because I don't have them printed out. Okay.
Wait, I can't come up with swag work.
What?
I can't come up with swag work.
I'll do it during lunch. Okay.
Wait, so it's worth the same as the test? Yeah.